So let's just see how we can insert a new node at a particular position in the circular singly linked list. In the list we have 3 nodes. So let's now see how we can insert one new node at any position. So we can insert this at the beginning of the list, in between the nodes, or at the end of the list. In the circular linked list we have 3 nodes. Now here we're going to write the function to insert one new node at a particular position. So the function will return one struct node type pointer. We're going to call the function insert at position. Now the function will take struct node type pointer head, and also it will take one integer data, and also it will take the position. So the function will create a new node with the data, and it will insert that in that specified position. Now inside the function, first of all we're gonna create one new node, struct node pointer new node with the data. So that means we have created a new node with a particular data, like in example 400. First of all we have to check if we wanted to insert at the head position. If the position is 1, so if we wanted to insert this new node in the beginning of the list, first of all we have to check if the list is already empty. List is empty, that means there are no other nodes left in the list, and the head pointer is pointing to null. If the head pointer is pointing to null, that means the list is empty. So in that case the head should point to this new node, and also this new node should have one self loop. That means the node should point to itself. So here we can do that. So new node's next pointer should point to the new node itself to create the self loop. So here we can return the new node as the new head node. So this is in case when we wanted to insert at the head and the list is already empty. But suppose we wanted to insert that in the head but the list is not empty. So in that case we need one temporary pointer which will initially point to the head, and then we have to use one loop and we have to traverse to the last node so that we can set the link from the last node to this newly created node, and then the new node should point to this head node, and then we can modify the head to point to this new node, and this way we can insert this new node at the head position. So here we're going to create the temporary pointer which will initially point to the head, and now we're going to traverse to the last node. So the temporary pointer is pointing to head. Now we're going to use the loop and we're going to traverse to the last node. So we're going to use the while loop, and the condition is the loop will continue as long as the temporary pointer's next node is not head node. And inside the loop, in each iteration we're gonna move the temporary pointer to the next node. So when this loop ends, the temporary pointer will reach to the last node. So now we have to set the link from this last node to this newly created node. So now we have to remove this link. Now this last node should point back to this newly created node. So here the temporary node's next pointer should point to the newly created node, and the new node's next pointer should point to this head. So the new node's next pointer should point to this head node. So we're done with setting all the links. Now the head pointer should point to this newly created node. So here we can simply return the new node as the new head node, and we are done. So this is when we wanted to insert the new node at the position 1. So let's now see if the position is not 1. So now we wanted to insert this new node at other positions. This can be in between the node or at the last position. So now we are using another temporary pointer, and we are calling this new pointer as current. So this will also point to the head. Now we have to move this pointer to the position where we wanted to insert the new node. So for this we can create one count variable. So the count will be initially 1, and now we're going to use one loop to traverse to the position where we wanted to insert the node. So we're going to use the while loop, and the condition is as long as the count is less than the position minus 1, and also the condition is the current pointer's next node should not be equal to the head, and in each iteration we're gonna shift the current pointer to the current next, means to the next node, and also we're gonna increase the count in each iteration. We're going to shift this current pointer to the desired position. So suppose we wanted to insert this new node at this position, so the current pointer should point to this previous node. Now we have to modify the links to include that new node in the circular linked list. So the new node's next pointer should point to this node, which is current pointer's next node. So here we can set the links. So the new node's next pointer should point to the current pointer's next node. So that means we are setting this link. Now this node, that means the current node's next pointer should point to this newly created node. So here we can set that the current node's next pointer should point to this newly created node. So now this node is inserted in between these two nodes. Now after the modification we can return the head pointer. So currently in the list we have 3 nodes. Let's now insert a new node at a desired position. So we're gonna call the function insert at position, and first of all here we're gonna pass the head pointer, the data like 400, and then the position. So first of all let's just insert at the first position. It will return the new head pointer. Now we can print the list again. So here you can see the new node 400 inserted at the beginning of the list. Similarly we can insert this at the position 2, and now you can see the new node 400 inserted at the position 2. So this is the way we can insert a new node at any given position in the circular singly linked list. So we can insert this at the beginning of the list, we can insert this in between the nodes, or even we can insert it at the last position. So hope you understand the concept. See you in the next one. Take care.